Okay, 10-1, the square root function. Okay, we've seen three different types of graphs. Okay, the first of which was the y equals x, and the y equals x looks like a straight line, boop, just like that. Okay, that's for y equals x. Actually, we've seen another graph. We've also seen y equals the absolute value of x. Okay, and the graph looks like a V, boop, boop, just like this. Okay, and the vertex, as you know, is at 0, 0. We have another one, y equals a to the power of x. Okay, when we graph this, it looks like this. Okay, where the important point crosses at 0, 1. Okay, another one. Okay, y equals x squared. It's a U-shaped graph, just like that. It's almost like a V, but it's actually a U. The last graph that we're going to be talking about is what's known as the square root of x. Boop, 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 and then x. This is actually an easy graph, but there's characteristics to this, okay? The key characteristics to this is as follows, okay? Notice how there's nothing on the left, there's nothing on the bottom either. Obviously, we can't square negatives, nor can we get negative answers. So the domain and range is not going to be all real numbers, okay? Notice the domain here, okay? The domain starts at 0 and goes all the way to infinity. So we can say the domain is restricted because any number less than 0 cannot give you an answer, nor can you get a negative as an answer, essentially. There are things that are a little bit different, though, when it comes down to when there's a negative on the outside. So let's use good old Desmos to figure this out. Oop, there that goes. Oop, there that goes. Okay, y equals the square root of x. Let's do square root of x. Let's zoom out a lot, okay, and go down, okay? There's the square root of x, but if I had a negative, boop, it actually flips it. So now there's negatives as answers. Notice how the negative's on the outside, meaning that now the function is on the bottom. Okay, it's on the bottom, okay? There's nothing different about radical x over 10. It's really, it just gets thinner, but the domain and range is still 0 to infinity and 0 to infinity, okay? That's crucial there, okay? Now, let's talk about moving the graph. Obviously, if the number's on the outside, we move the graph up and down. Boop, boop, boop. Notice how from here to here it moves. The important point in the beginning was 0, 0. Now the important point moves to 0, 3. Okay, so that also tells us h and k essentially. When the number is inside, we move it left and right. If it's positive, we move left. If it's negative, we move right. So if it's positive outside, we move up. Negative, we move down. Okay, let's talk about these here. How does each graph compare to this graph of the original function? For radical x minus 4, okay, we move it down 4. But we move it like that, okay, where the important point now is at 0, -4. Boop. For this x negative 10, we're going to move it to the right 10, beep, bop, beep, bop, beep, bop, beep, right there, boop, and then it's going to be 10, 0, okay, from that there. Not difficult at all, okay? Understand, we've done this a million times, okay? Now, when we talk about average rate of change, again, when we see the words average rate of change, we find the slope. We need to find the slope. In order to do that, we need to find the answers at these x's, and then from there, notice how we are finding the slope. Just like that. It's not difficult. Okay? So, let's do this one here real quick. Okay? 2 or radical 2x for 8 and 10. Let's just do 8 and 10 for now. Okay? Let's find the answer at 8 first. Okay? So, h of 8 is the first one we're going to find. And we're going to plug in radical 2 times 8, which actually we can find mentally. That is going to be 4, okay? H of 10 is going to be radical 2 times 10. That's radical 20. And if I'm going to take the square root of 20, here we go. Let's do it. Radical 20. Let's get the decimal for this. It's going to be 4.47. Okay, 4.47. So let's set it up real quick. 4.47 minus 4 over 10 minus 8. That is going to be 0.47 over 2. Boop, we have our answer. Okay, all there is to it. Okay, for this last one here, very, very straightforward. all you got to do for this is basically plug in the number and then you have your answer. Notice how for this question here, if the ride has a radius of 3 meters, which plan will result in the greater speed for the ride? Just plug in R for 3 because that's the radius, beep, bop, boop. It's 8.7 meters per second, okay? We're doing the same thing with this. You're just plugging in 17 for X. Notice the difference, okay? There's a radical on top compared to the radical around the whole fraction. So there's actually a big difference. We're gonna plug in 17. Let's do that real quick, okay? So I'm gonna have radical 17, okay, divided by 10, boop, there you go. Or let's do radical 17 divided by 10, big difference, okay? Big difference because they're written differently, okay? This is not a hard lesson, okay? Not a hard lesson. Enjoy 10-1. Have fun. Understand that this right here identifies that you're working with a square root function if it looks like this. Notice how it does not continue from the bottom. If I see this, that means you're wrong, okay? It does not continue down then up. It only continues from a starting point and then continues to the right forever, depending on the direction that you're graphing it. Very important. Okay, have fun. That's 10-1.